All right. Thank you, everyone. Welcome to the OpenTimelineIO 2025 Town Hall. It's great to have you all here. OpenTimelineIO's technical steering committee is Josh Miner, Stefan Steinbach, Nick Porcino, Jeff Hodges, Roger Nelson, and myself. I'm Eric Reinecke, and I'm the technical steering committee chair. Today, we're also going to be hearing from some guest speakers. We have Darby Johnston, Cameron Kerr, Anton Marini, Yingji Wang, and Sam Richards. So let's get started and get into first the overview of OpenTimelineIO, get you introduced. So filmmaking is a complex process that involves handoff between many different disciplines, departments, and collaborators. Creative decisions made in editorial need to be communicated quickly and clearly to everyone else. Each discipline uses specialized tools, and each of these focus on specific workflows for specific users. OpenTimelineIO began as an effort to streamline the animation and visual effects filmmaking process. VFX and animation studios tend to have software developers building custom pipeline tools, and OpenTimelineIO came from the desire to make robust, flexible, and reusable tool sets in these pipelines. These benefits can extend to all forms of filmmaking, and so OpenTimelineIO aims to facilitate communication by streamlining interchange within and between all parts of the filmmaking process. Here is a timeline view for 20 minutes of Toy Story 4. All these video and audio tracks, thousands of clips, and every splice and transition are built up over years of creative filmmaking decisions. And as the film evolves, the producers, writers, and artists working on the film are hungry to know what has changed in the cut, how do those changes impact their work in progress, and what new media do they need to deliver into editorial to improve the film. OpenTimelineIO is designed to help communicate this timeline in all of its complexity through the filmmaking process. So let's get into what OpenTimelineIO is exactly. And it's all kind of in the name here. It's open source, it's for editorial timelines, and it's interchange format. So specifically, the open source aspect is about it being by and for developers. It provides a positive developer experience for technical artists, R&D engineers, and application developers so that they can quickly implement, quickly integrate with it and use it. The data model deals with all the timeline structure seen in audio and video editing applications, and it generally feels pretty familiar if you're used to looking around in an NLE. OtioDiff's data is saved in a .otio file, which is a specific flavor of JSON. Users can import and export OtioDiff from many applications, and for applications that don't yet support OtioDiff, there's a collection of file format conversion plugins for some of the more common ones. OtioDiff's file format and API have a unified data model with concepts like tracks, clips, transitions, markers, all those sorts of things. And most of the things, these are, most of the things you might see in an audio or video editing application, and they can be represented in OtioDiff. An OtioDiff file does not contain the actual media itself. Instead, it uses media reference URLs to point out to the audio and video media in whatever format or location they are. OtioDiff and OtioDiff and OtioD bundle an OtioDiff and the reference media into a single package. This makes it possible to keep the timeline and the media together for delivery or archival without fear of anything getting lost or unlinked. OtioDiff's core is written in C++ and includes language bindings for Python, Swift, and C. This means that all those languages have access to the same feature set in the underlying implementation, and developers can use the language that best suits their application. File format adapters convert to and from a wide variety of other formats. Editorial formats kind of exist on a bit of a continuum of functionality, and while OtioDiff is very capable, exceeding CMX EDL in capabilities, there may be things that are yet to have first-class modeling. Luckily, the adapters tend to use Otio's extensible metadata to preserve that extra information, and pipelines can go look for it in the metadata fields or in Otio's metadata fields. Since adapters are Otio Python plugins, the system can be extended to support common formats in use in the industry, as well as custom playlist formats that might exist in studio pipelines. Allowing transparent loading and saving of other formats in pipelines using Otio Python is a useful tool when migrating your pipeline to OpenTimelineIO from older formats. When all the applications in your pipeline support OtIO, you can be sure your metadata is going to be preserved through any sequence of handoffs between the applications. Here we see a collection of applications which all have some level of OtIO support. And as both OtIO and support for its features evolve, we hope to see interchange become more and more seamless and achieve this dream. Raven is an OpenTimelineIO viewer application that's also available as part of the OpenTimelineIO family of projects. Raven allows you to load up an OtIO file and visually explore the structure and detailed metadata for developing and debugging purposes. This tool provides a quick way to pop open your OtIO timelines and see what's going on without dealing with the media management or launching a heavier application. If you're not all using Raven, I encourage you to go give it a try. Here's the URL for it. It's under the OpenTimelineIO GitHub organization. Sample OtIO and OtIO-Z files are also available for testing, verification, and presentations, and this is incredibly helpful. The ASWF Digital Production Example Library hosts real production data sets under a license which permits such use, while also balancing some restrictions that satisfy the studio concerns about releasing open content. Here you see featured the Animalogic A-Lab trailer and the AWS Pichu short film, which both have OtIO assets available. To download these and more, go visit dpel.aswf.io. And if you have anything you think might be good to contribute to DPEL, we encourage you to reach out to that group in the ASWF as well. So one of the other things we can talk about is OtIO's first-party support, which has been really blossoming, and we have a lot of folks getting on board. In addition to the ones you see listed here, we also have Blender and Matchbox and a few others. The past year is, for the past year, Avid specifically has been hard at work, and as of release 2025.6, they now both have import and export support in Media Composer. The Avid team have been really great partners in the OtIO community, and we're really excited to continue collaborating with them. So we want to give a big thank you to Avid for everything they've been providing to us. So if you'd like to join our community, we invite you to attend our biweekly OtIO TSC meetings, which the technical steering committee gets together every other week and talks about things. This is open to anybody to participate in. Come ask questions in our GitHub discussion forum, and our OtIO Slack channel in the ASWF Slack instance is a really great way to get involved in our conversations. There's links over at OpenTimelineIO to all these things, so please go find those and get involved. So I'd like to transition now to talk about some of the things that are kind of new since we last spoke at one of these town halls for 2025. Over the last year, there's been a lot of usability and maintainability updates in addition to the ancillary apps really growing out. We've got some really exciting schema enhancements in addition to all this that are all pretty far along in the design, and so we hope we'll see some of that work start to show up in the code base in the next few months here and over the course of the next year. But specifically, I'd like to talk about some of the new features in Raven. Thanks to our community and the ASWF Dev Days, Raven has received some really great updates over the past year. You can see them, a bunch of them listed here. And I want to just give a big shout out to some of our contributors from the community in addition to Josh Miner's leadership on this. We have Thomas Wilshaw, Trevor Allyward, Justin Witherspoon, Fernando Ortego, and Yash Jain, who were big contributors throughout the year to this. I think one thing I'd like to highlight is that in addition to all these great usability enhancements, there's now the ability to load OTIO files using the WASM compilation of this through JavaScript. So that means that this can be used in a web browser as an OTIO viewer and load files from URLs or wherever else. So that's a really big step forward for Raven, I think. Also, while Raven provides a UI for exploring the data model of an OTIO file, Toucan is a project that was contributed by Darby Johnson for rendering out for rendering out the visual timeline described by an OTIO file. And we're really excited to have Toucan as part of the OpenTimelineIO family of projects. We'll see a little bit more about Toucan from Darby later in the presentation. You can go check out Toucan's repo, which is also under the OpenTimelineIO GitHub org alongside of Raven. So now we want to go on and let's highlight some contributions from guest speakers that some things that they've been up to with OTIO over the past year. First, we're going to look at OtioDiff, which will be presented by Yingji Wang from Pixar.
Hi everyone, my name is Yingji, and this summer I'm interning at Pixar Animation Studios in the Software Research and Development team. Specifically, I'm working with Josh Miner on the story and editorial tools.
Oh, sorry.
Hi everyone, my name is Yingji, and this summer I'm interning at Pixar Animation Studios in the Software Research and Development team. Specifically, I'm working with Josh Miner on the story and editorial tools team, and as part of my internship, I'm working on OtioDiff. OtioDiff is a visual timeline comparison tool to compare different OTIO files. The goal for this project is to be able to easily compare two OTIO files and figure out what the differences are between the two. Our target users are editors, and after speaking with editors at Pixar, we discovered that they really want to know what has changed between iterations of a sequence or scene in our feature films. Their main areas of interest are in clips that have been added and deleted, as well as timing changes. Clips that have been shortened or lengthened. Clips can also have different versions looking at their video media files. However, this versioning is of less importance. So how do we actually figure out what the differences are between two OTIO files? Well, let's walk through an example. I pulled this data from the digital production example library, and as you can see, there's a ton of different versions. Let's say we want to look at version 81 and 83, and let's call them OTIO A and B. So there are text diff tools out there that are commonly used. However, this can be really difficult to parse, especially since OTIO files can get up to tens of thousands of lines. And we also lose context of what the track a clip is on or where it is in the timeline. We can also open these two files in a video editor or in Raven. However, doing a visual scan of the two, you can kind of see the differences, but it quickly becomes a spot the differences game, and it's difficult to pinpoint every single difference that there is. So to address these problems, I created OtioDiff. So how OtioDiff works is it takes in two OTIO files. It processes and categorizes the clips that are within these files, and then it creates an output OTIO file as well as a text summary. So specifically, how do we look at the differences and figure out what has changed? Well, we look at the clips and based on the name, we match the clips to see if they're correlated. And for correlated clips, we look at the start frame and duration to see if it has been edited. We can also figure out clips that were added and deleted based on the names as well. So taking all of this information, we can output an OTIO file that contains this. So this is what the output OTIO looks like. In the bottom half, we have OTIO A and the timeline from there. And in the top half, we have the timeline from OTIO B. And these two timelines are annotated with the changes that have occurred. So green means added, orange means edited, and red means deleted. And this allows us to really easily see the differences between these two files and start to kind of analyze what has changed. So we can see, like, for example, in the beginning, these are orange, so there were some timing changes. There were some replacements happening where the old ones were deleted and new clips were added in its place. But perhaps more interesting is this middle section where we can see two clips got deleted and replaced by a single clip, and the two clips that surround that clip actually got shortened to make space for it. So this way we can very easily see kind of like these changes and figure out their relationships, looking at it in a single view. And one of the benefits of outputting this as an actual OTIO file is that you can pull it into your favorite video editor and see it directly within the context of your video editor. So this is the same OTIO file, but open in DaVinci Resolve. The colorings here are hand-colored since clip color isn't supported yet, but we hope to add that support in the future. OtioDiff also outputs a text report that summarizes the changes, including the count of all of the changes as well as the names. So you can easily see the specific names of the clips that were changed. This project is currently a work in progress, and we're still experimenting with ways to best visualize this information. This is one of those where we label all of the changes with markers. And markers are really cool because they have this comment field that allows you to add some text that can explain more in detail. So for example, for edited clips, we can show that this specific clip was trimmed by 8 frames. And this allows us to also showcase some of the semantic parsing that OtioDiff does in the background. We took OtioDiff back to the editors to ask for some feedback, and they really liked it. They said that they can clearly understand what the differences are. They like how they can pull it into their video editor, and the semantic information about the clip lengths was actually really helpful. So looking forward, we want to further iterate on OtioDiff and also improve the handling for duplicate clips as well as clips that have moved between tracks. We're also looking to add this into OtioTool, which is the command line utility for OTIO. So that was a little bit about OtioDiff. If you're interested in learning more about it, feel free to reach out to me in the Academy Software Foundation Slack. And thank you so much.
Thank you for that. That's pretty exciting to see. I think a lot of people are probably really excited about when they can get their hands on that and start playing with it. So thank you for presenting that, Yingji. And let's move on. So next we have Cutlist, which is a tool that Cameron Kerr is sharing with us.
Hello, my name is Cameron Kerr, and I'd like to give you a first look at an app that I'm working on that uses OpenTimelineIO. It doesn't have an official name yet, but I've been calling it Cutlist. Cutlist is a way to get your shot and clip information out of your timeline and into your project management solution of choice. Let me give you a demo of how it works. You drag your OTIO file onto Cutlist, and it parses it and displays it in this nice little table view. If you have an offline video file, you can drag that on as well, and it'll generate your thumbnails. Now the app knows your naming convention, and you can enter in whatever naming convention you'd like in settings. So a single shot that has more than one clip or plate, it can group them together like this. Now this is just some basic data, but one of the great things about OpenTimelineIO is the ability to store custom metadata. Let me show you the workflow that got us here to this OTIO file. On set, the sound department and camera department, DIT, and others are all capturing their own custom metadata. It all gets passed along to the dailies lab, who not only generates the dailies MXF files for editorial, but they also maintain all of that metadata and send it along as an ALE so it can be imported into Avid Media Composer. Once in Media Composer, it's already associated with all the clips in our timeline, so it gets included when we export our OTIO using Media Composer's list tool. Now let's take a look at this OTIO file and see what's available to us. Look at all of this custom metadata. This all came from set, through the dailies, into the Avid, and out into this OTIO file for us to use. So, how do we access it? Well, let me hop back into Cutlist. I'm going to go into my settings here, and into my column settings, and I've set up a couple of these columns ahead of time. Let me just turn them on. But I'm going to show you how easy it is to add OTIO custom metadata to a column. Let's say that I'm looking to add focal length. Content type, I'm just going to select OTIO metadata, and right here I can start typing, and it will do an incremental search of all the OTIO metadata from that file. There's my focal length. I haven't talked about flow yet, but I just know that SG focal length is what my field is called, and I'll show you where that comes in handy a little later. And I'm going to hit apply. Close this, and if I scroll over, here are some extra columns with custom metadata from that OTIO file. So what do you do with all this data? Well, you got to keep track of it all. Depending on your project, you may just be tracking in Google Sheets or Excel, and you can use Cutlist to export a CSV. The CSV export button is right here. And now we have a CSV that we can go and take and import into Sheets, Excel, Airtable, or anything else that you might use that supports CSV import. Cutlist also integrates with Autodesk's Flow production tracking. This is the SaaS product formerly known as ShotGrid, and this little cloud upload icon button right here will upload all your data to Flow. All shot info gets uploaded, and if you generated thumbnails, they will get published to Flow too. When the upload is done, you get this nice little summary sheet, and here is where you'll also see if there have been any changes since the last upload and what those changes were. Let's close this and open up Flow. Let's hit refresh. And there are my shots, all my data, and if I scroll over, all my custom metadata from OTIO. Now, I just chose a select couple of columns here, but you start to see how powerful and easy this is. Tracking down this information before OTIO was really a pain, especially if you don't have TDs or an established pipeline. You've got to go and find it from a couple different source files, maybe email people if you don't have the files, no more. Thanks to OTIO, not only do we have easy access to it, but it can be parsed by Cutlist, tracked in your management tool, and passed along to other parts of your post-production workflow. So that's it. That's OTIO in Cutlist. A big thank you to the TSC and all the contributors to OpenTimelineIO. I hope to have Cutlist ready very soon. Thank you.
And thank you, Cameron. That's a really great example of the point OpenTimelineIO is getting to between our ecosystem adoption and tool sets available like the OTIO Swift bindings. You now have the data in the right place to be able to get this information out in a way that you can easily access it so you can carry it forward through your pipelines and start to put together really powerful and simple tools. So thank you, Cameron. That's a great demo. Next, speaking of Swift, we're going to move on to AVFoundation OTIO, which is presented by Anton Marini.
Hi, my name is Anton Marini. I'm going to take you through the OpenTimelineIO for AVFoundation integration and Swift package, which can be found at github.com/OpenTimelineIO. OpenTimelineIO AVFoundation. Please join, ask questions, help out, contributions, very welcome. So this is an example image of the included OpenTimelineIO renderer, and that should give you a sense of what this project is sort of for. And so what this project does is it's a Swift package for specifically Apple platform interoperability with OTIO. And it builds off the existing OpenTimelineIO Swift bindings that are cross-platform. So if you didn't know, you can actually use Swift on other platforms and natively load and introspect OTIO files wherever you like. But this package is going to leverage all of the Apple-specific platform tools to preview, playback, inspect, and in real time make edits and even export your OTIO files. So we'll support native QuickTime formats. We have some conversion methodologies and routines that are included, as well as some Swift UI code to visualize the timelines, the tracks, the markers, etc., in a nice standard way. So this is an example of the AWS, I don't know if I'm going to say this right, the Piku edit, which is a slightly more complicated edit. But as you can see, we're able to load it and we're able to preview it and play back the media in real time here. And I'll show a demo in a beat. So quickly, the OTIO to AVFoundation path, assuming you've got a timeline loaded somehow, either from JSON or from a URL, you can create a trifecta, a recipe for real-time playback. And you do this by calling two AV composition renderables. And what this will do is create a composition, which is the instructions of the edits of all the different media as described by OTIO. The video composition, which is the presentable layers of how the video is rasterized and rendered on the screen. And then the audio mix, which is the instructions for AVFoundation to mix multi-track, multi-channel audio in a way for real-time playback. And once you have those three things, you can combine them with the standard AV player pipeline and use that with a view of some kind to preview and playback your video. That's pretty cool. And then the other way around is AVFoundation to OTIO. And so you can use the AVFoundation APIs to build a mutable composition, which is the instructions for what constitutes the assets, its tracks, and its in and out times. And then you can pass that through the composition and convert it into an OpenTimelineIO timeline, which then you can save and use as an interchange format. And so finally, we also provide some Swift UI views that allow you to preview and interact with and introspect in a Swift UI native view hierarchy. And you get a multi-track timeline that is scrubbable, zoomable, selectable, and should preview your media references, your clips, your gaps, and all of that things that are a part of your OTIO file. So for a quick demo, what I will show here are a few different OTIO files. So here is the AWS, or sorry, the ALAB preview video here. And as you can see, we're able to scrub our media references here. We're able to play it back. We have audio playing, and we have a selectable interface, which will update the edits that show up here on the right-hand side, which is the little inspector panel, and we can view the root metadata. We can view different information about the clip that we've selected that's been edited, in times, frame rates, and then all of the various debug information that's been parsed by OTIO. And this is a slightly more complicated timeline here, so I'll zoom out and give you guys the view, the full view here. Let's go all the way back here. So this is the AWS edit. And one of the things you'll notice is that there are some limitations today. The limitation right now for us is that we don't support image sequences. So if you have your content referenced in your OTIO file as a QuickTime compatible video file, that will play back great. But if you happen to have a media reference that is pointing to a set of image sequences, we don't currently support that. But here is the beautiful interface in OpenTimelineIO colors. And one of the things that we can also do, because we've built a composition native in AVFoundation, is we can actually export it. So I won't do that live, but it's not too slow. But you can see here we've got an exported version of our AL lab, and that includes audio, obviously the video, and the edits exactly as previewed in our preview here. So that's pretty cool. So this is a nice, quick interchange and validation tool built in. Okay, so let's talk a little bit about the nuances of going back and forth between AVFoundation and OTIO. There's a whole bunch of components in here. We won't get too into the weeds, but effectively, there's a set of conversions that happen between OpenTimelineIO and AVFoundation, and the Swift package allows for extensions to natively move between the two representations as you need, which is quite nice. And you can find that in the extensions inside of the project, and there's a whole slew of extensions to move between time ranges and CM times, CM time ranges and rational times to whatnot, external references to clips and AV URL assets, and all the things you need should be there. So current limitations, obviously codec support. Right now we're relying on AVFoundation, i.e. QuickTime. Best thing you can do is install the Pro Video Codec package from Apple, and that gives you a bunch of things that you might not get in the stock OS. And if you're unaware, there's a really cool new API that Apple's providing called Media Extensions that lets you do new codecs system-wide and supported with very little work, as long as the extension is enabled. And that can add support for different codecs. Image sequences, however, do require, it seems like, a little bit of special work. So this is DIY for now. It's fairly straightforward, but we don't support that right now in the product, or rather in the project. And then finally, transitions and effects. Once the OTIO working group finalizes the set of transitions and effects, we should be able to render that in real time using our custom compositor, but that's work to be done. So overall, that's AVFoundation and OTIO project. Please contribute, please ask questions. Any input is welcome. Thank you so much.
Thank you, Anton, for sharing that really powerful tool set for developers using OpenTimelineIO on Apple platforms, particularly being able to convert back and forth between things like CG-rect and the vector types, or rational time and CM time are kind of must-haves for a lot of that sort of thing. So thank you, Anton, beyond all the amazing other AVFoundation things. Next, let's move on to Sam Richards to talk a bit about open annotations.
Hi, I'd like to present the annotation interchange format, a way to use OTIO to interchange annotations and notes between different review systems. So we're going to focus on how do notes get from the vendor to the production hub, submitting with particular requests, and how do those notes come back potentially with annotations. How do we get the databases from the production hub, be able to talk to the vendor's production management database, and ultimately how do the artists get those resulting notes. So currently, typically the easiest solution is simply exporting a PDF which is then just emailed to the vendor, which is not a great way because it's not ingesting into the vendor's annotation system and possibly not getting to the artist. So for now, we're focusing on four things. What are the notes that need to be sent to the reviewer about what they're reviewing? Are they doing is this a work in progress? Is there particular things they should be looking for? What are the notes coming back? Are there annotations associated with what's coming back? And is there any other kind of review metadata? And at some point, we probably also want to look at, is there some way to record the whole session so you could maybe sync it back with audio? We also want to review, so leverage as much of the existing technology. There's a lot of great stuff that's in OtioIO coming up, like the color management and so on. And we're also looking at using the sync protocol that's syncing between OpenRV and XStudio, and we can use that for other things in terms of like how we actually capture the brushstrokes themselves. OpenTimeline is we're looking at having the actual annotation images, because we talk about PNGs as well, and those that actually just exist on a separate track. Now there may be other places to store the notes and annotations, and we also we're not relying on images. They're just there for certain scenarios. So in some cases we'll still have the vector brushstrokes. Here's a quick demo of this playing back. The OtioIO annotation interchange format. So we're trying to store these annotations inside OtioIO and make a usable OtioIO file that can be used outside of whatever the source application is. So here we're inside RV. I'm going to go to Tools, Export. And I'm going to pick an export directory. And then the reason I'm picking a directory is because I also want to export the media with it. So it's a sort of self-contained format. And now I'm going to bring up Resolve and import that same OtioIO file. And you can see there are actual clips in there. It's a second timeline. If I actually just roll that down, you've now got a separate track which has all the annotations on it. So you can actually go to a particular place. You can easily turn them on and off. See the original, go back. And the reason to have it as a timeline is potentially you could have multiple layers of review. So different people may be commenting on it, so you can see each of the sets of reviews separately. We also need to have an API for actually storing, be able to, this format isn't necessarily easy to get then into, or trivial to get into your databases or out of your databases. So we have an API which does all that wrapping for you to make that ingest and export as easy as possible. It's still early days on this project, so we definitely encourage you to be involved. There's 2 Slack channels where this is getting discussed. One is the Open Review Initiative, and the other is the OpenTimelineIO. There is a Git repo, as well as later this week. There's actually 4 different virtual town halls. One is the ORIO coding guidelines. I'll be presenting 2 new intermediate codecs. There's virtual town halls on XStudio and OpenRV, and a shared plugin platform which is designed to help you develop plugins on top of both review systems or any review system. And on top of that, we'll probably end up using that extensively for the annotations guidelines. And lastly, there is if you're attending SIGGRAPH, there's a BOF on Monday morning at the grand old time of 8 a.m. So hopefully I'll see you there.
All right. Thank you, Sam, for that. I think I'm just going to repeat what Sam said. One, he's been doing amazing work over in the Open Review Initiative more generally, but this effort particularly with having rich annotation metadata in OtioIO is really cool, really interesting, and it's early enough on that if you have use for this stuff, you should get involved and really see how it works for you and get feedback. So thank you again, Sam, for sharing that, and hopefully the rest of the community will jump in there. Next, let's move on to hearing from Darby Johnston to hear a bit about Toucan.
Introducing Toucan by Darby Johnston, available now on GitHub. Toucan is an open source project for rendering timelines. It includes a command line renderer and interactive viewer, and is based on multiple ASWF projects, including OpenFX, OpenImageIO, OpenColorIO, and OpenEXR. This slide shows a timeline with multiple clips, tracks, and effects next to the image processing graph representing a frame on the right. Let's take a closer look. In Toucan, we start with our background video layer. Next, we add our composite layer featuring Charlotte. To see the node graph, go to the Graph tab in the Inspector window. You can see the nodes in the panel. Next, let's render a text layer. Note that the text render is at the track level. Let's add a wipe effect. And finally, we'll layer in more effects. You can zoom in and out for more detail. You can download Toucan from github.com/OpenTimelineIO/Toucan. And for more about Toucan, email Darby at grizzlypeak3d.com.
Thank you, Darby, for that. Toucan's one of the projects I've been really excited to have folded in under the OtioDiff umbrella. The idea of being able to use a command line command to render out an OtioDiff file is extremely powerful, and then stack on top of that the UI that Darby's put together for it. It's a really exciting thing to play with. So I encourage you all to go check that out. Next, we're going to hear a little bit more from Darby about Kdenlive support for OtioDiff.
Grizzly Peak 3D's Darby Johnston collaborated with Kdenlive on the successful implementation of native OpenTimelineIO support for the popular open source nonlinear editor. Here's how it works. Open Kdenlive and go to File, Open Timeline Import. Select your OtioDiff file to open it on the Kdenlive project timeline. Edit your content, and then go to File, Open Timeline Export, name your file. Next, let's open the new OtioDiff file in Resolve. Go to File, Timeline, or press Ctrl-Shift-S. Select the OtioDiff file, open the Edit workspace, and seamlessly play back and update your edited sequence in the timeline. Import and export timelines while preserving essential editorial data, including multi-track and multi-clip structures, guides and markers, basic transition data, and color clips. The ongoing roadmap for this integration includes support for OpenTimelineIO archive bundles, which introduce a new way to package the timeline and associated media together for both archival and delivery needs. Image sequence clips, multi-timeline projects, round-tripping metadata, which makes interchanging with other systems more seamless, along with improved support for timecode. For the free Kdenlive download, visit kdenlive.org. For more details about the OtioDiff integration, contact Darby at grizzlypeak3d.com.
And once again, thank you, Darby, for that. That's a really exciting one to see. Kdenlive had some early OtioDiff support, but this represents a real step forward in that. So that'll be a great tool for editors that want to adopt Kdenlive. So now I want to move on to talking about where we're looking to turn our attention next in OpenTimelineIO. Looking forward, these are some of the exciting things that we see as key features we'd like to see in OpenTimelineIO. And some of these things are easier, some of them harder. They're each going to have their own roadmap. Many of them are living at that place in the roadmap where the design is nearly complete, and then we're ready to start picking up and implementing them. But again, there will be an iterative cycle as each of these things roll out. Now, these are all things that we're really hoping that the community will jump in and collaborate with us on, because while we as the OpenTimelineIO TSC have quite a bit of exposure to these things, I think you all out in the world that are using these things know a lot more than us in some places. So having that help will be really beneficial and make OtioDiff be the best it can be and help us get those things out into the world more quickly. And just taking a step and looking backwards, since we've looked into the future before we conclude, I just want to take a moment to reflect on something real quick. Like most big ideas, OtioDiff's origins have come out of a lot of conversations and a lot of hallways across a bunch of studios and companies and things where people really knew that we could use something like this. But 10 years ago, Josh and Stefan first presented OpenTimelineIO publicly at SIGGRAPH 2015. Here's the intro slide from that presentation. And I'm happy to say I think it still resonates today. I think this is when we can say OpenTimelineIO really started, was at this presentation a decade ago when they invited collaborators and created OpenTimelineIO, the OpenTimelineIO community we know now. So we've come so far as a group working together on this, and I really can't wait to see what we all do together next. So with that, I want to invite you all to be part of what's next. We openly invite everyone to attend our bi-weekly technical steering committee meetings. They're open for participation, and we love to have discussions in there with people. Ask questions on our GitHub discussion forum, or come into our OpenTimelineIO Slack channel, where we've always got lively conversations going on, and you can tell us about something cool you've been doing or ask really specific questions about things you might want to do with OTIO. And then finally, we're participating in ASWF Dev Days, which will be on September 25th, 2025. And a bunch of the contributions you saw on Raven earlier actually came from Dev Days earlier this year. We encourage you to go to aswf.io/dev-days to register for that, and you can participate in OpenTimelineIO or a bunch of the other ASWF projects. You can get links to a bunch of this stuff at OpenTimelineIO or at aswf.io. So with that, I'd like to thank you all for joining and open it up for questions and Q&A if anybody's got anything. Or if we've just done so well that we've answered every question, we'll be happy to say thank you. All right, everybody. Thank you for joining us today. And of course, if you have any other questions or want to talk to us about anything, please join us in all those other places at OpenTimelineIO. And please check out all the other open source days programming this year for other great presentations by ASWF members. Thank you all.